Good morning, students. My name is Kalpana and I welcome you back to another session of data structures. In this PPT, I will be explaining the topic searching, that is the topic in Unit 1, and this is my class 3. In this PPT, I will be explaining the process of searching, the searching techniques, that is linear search, binary search and Fibonacci search, and linear search with example and algorithm. Now coming to what is searching. Searching is nothing but a process of finding a particular element among a given list of elements. That is, if we want to find any data or any element in a given list of elements, then we use the searching procedure. If we find the element, then we say that the search is successful. Otherwise, we say that the search is unsuccessful. We have a number of searching algorithms in computers for the process of searching. Now, in computer science, what is searching? Searching is nothing but finding an element or finding a file in a collection of files or collection of items. In a regular example or in our day-to-day life, we can say that searching is nothing but like searching for a person in a searching for a missing person, searching for a person in a group of persons. That is called as searching. These searching algorithms are used for searching a file in a group of files that are stored in the databases, and searching for an element in an array, searching for a node in a tree, and searching for a vertex in a graph. Everything comes under searching only. In short, I can say that searching is nothing but a process of finding an element in a group of elements. Next, why do we need searching? In today's world, we have to store a lot of information in the computer, and after that we have to retrieve it. Retrieve means get that information back whenever we want. Such a time we perform the operation of searching. That is, you can take the example of storing information about all the people in an area, that is census, taking the census in an area, everything, and searching for a person's details in a list of persons. It comes under searching. Searching is one of the core computer science algorithm. As we perform searching in our real world, searching is also done in computer science. This is done using the computer science algorithm. Searching is nothing but deriving or retrieving an element from a group of elements. For performing searching, we need different searching algorithms. Out of them, we need the very efficient searching algorithms to perform our search fastly, efficiently, and very quickly. Now, coming to the types of searching techniques. There are different searching techniques, and they are linear search, binary search, and Fibonacci search. Now, linear search. This linear search is also known as sequential search. That is, the element to be searched is searched in a sequential order. That is, starting from the beginning of the array, one by one element is compared with my key element and my search is performed. If I find the element, then I say that the search is successful. And if I don't find the element which I like in the list of elements, then I say that my search is unsuccessful. The element I am searching, the element for which I am searching is called as key element. I compare my key element with the elements in the array. If I find the correct match with my key element, then I say the search is successful. Otherwise, I say I am unable to find the key element in the given list of elements and my search is unsuccessful. First, I start from the beginning of the array, that is where the elements are stored. Then from the compare my key element with the first element, then with the second, then with the third. If I find the element at the third position, then I stop my search and I say that my search is successful and I have found the element in the given array of elements. At which location I have found, that also I can say clearly. If I don't find the element, I search till the end of the array, that is till the list of elements are over. Then if I don't find the element, then I say my search is unsuccessful and my element is not found. Next, coming to binary search. This works on sorted array. This binary search technique works on sorted array. That is, if the elements in the array are arranged in an ascending order only, then only I can perform the binary search techniques. That means the list of elements that I store in the array should be in the sorted order, that is in the ascending order. Then only I can perform the binary search technique. In this binary search, we apply the divide and conquer technique. The divide and conquer technique means the whole list of elements are divided into two sets, and after that we compare with the first set or the second set to find the desired or key element. This searching algorithm is very efficient when the array is sorted array. That is, when all the elements in my list or array are in sorted order, then I can apply the binary search technique, and this technique is very efficient technique, and it is also an advanced type of searching algorithm that finds an element in a list of items or elements. Next, the third searching technique is the Fibonacci search. In this searching technique also, I use the divide and conquer technique. The divide and conquer technique will be explained clearly in my next sessions to be coming. That is, in the quick sort algorithm, I will be explaining the divide and conquer technique, since the quick sort algorithm is based on divide and conquer technique. For now, I will be just giving a brief idea about divide and conquer technique. Divide and conquer technique means nothing but the whole list of elements, say 10 elements, will be divided into two halves, that is 5 and 5. And after that, this 5 elements will again be decomposed or divided into two sets, that is 2 and 3, and again this will be divided into two sets, and then after this they will be sorted and sorting the last decomposed set means sorting the main set. This is similar to the functions concept that we come across in C language. That is, the main function or one function will be divided into sets, and again that will be divided into small modules. Solving these small modules means solving the main task or main problem. This is one of the improvement technique in binary search. That is binary search better than the binary search, we can say. It uses the Fibonacci the number, that is Fibonacci number. It generates a Fibonacci number, and based on that the searching procedure will be done. Now coming to the concept of arrays. In this searching I am going to explain arrays because everything is related to arrays in the searching process. That is in the array, as we all know, array is nothing but a homogeneous collection of similar data items stored in continuous memory locations. Once again, array is nothing but a collection of similar data items stored in continuous memory locations. Why is this array used in sorting? For sorting a list of elements, we have to take all the elements or all the list of elements in an array. As we can see the list here, the elements 20, 30, 40, 50, 25. Here the elements are stored in the array. Like this only, whatever the list of elements are to be sorted or searched will be taken into the array. It means an array contains only, if I declare an array as integer array, it will contain only integers. If I declare my array as character array, then it will contain only characters. And if I declare it as floating point number, then it will contain only float point numbers. Now, so here in this syntax, I have declared an array int a of 5. That means my array is an integer array. Then it can store only integer values, and its name is a. Here I have given a. You can give any name that is related to the program. You can give the name, and my size is, that is array size is 5. I have given the array size as 5. That means the locations will be, I will be allocated 5 memory locations for storing the data. And after storing the data in this array, I can perform the searching or sorting techniques. So I am demonstrating the array concepts here also. Next, what is a sorted array and what is an unsorted array? A sorted array is a data structure in which all the elements will be in particular order, that is ascending order or descending order. That is, if the elements in the array are in some particular order, then it is called as sorted array. See, it can be numerical order, alphabetical order, or any order. See the first array which contains elements 20, 40, 84, 121, 134, and so on. Here all the elements are arranged in ascending order from small to big. So it is called an sorted array. Elements are arranged in an order based on the small to big. So it is called a sorted array. Second type of array is known as an unsorted array. In this array, all the elements will be arranged in an different order, not following any order. They will be scrambled here and there. That is, see, in this array 14, 33, 27, 10, 35 and so on are not arranged based on any order, that is in ascending order or descending order. So it is called as unsorted array. These concepts are very important in any searching or sorting techniques. So I am explaining this concept. Here in this, I will be giving a clear idea of linear search procedure. This linear search procedure is also known as sequential search. That is, I move in a sequential order from one memory location to another memory location, searching for an element from starting first position of the array, that is A of 0. then I go to A of 1, then I go to A of 2. Like that I will compare from first location to the end location in a sequential order. So it is called as a sequential search, and it is the simplest searching algorithm, and this does not need any sorted or unsorted array concept. The elements can be in any order. So yeah, I don't need to sort an array or unsort an array. I can keep the elements as it is, as they are given to me, and start the searching technique from the first location. I compare my element, that is my key element to be searched, with the first location, A of 0. Then if it is found, and if the search is successful, if my key element is matching with the first memory location element, then my search will be successful and I can come out. Otherwise I will go to the next location, that is A of 1, and after that A of 2, and after that A of 3. Like that I will be comparing my key element, that is the element to be searched, with the memory elements one by one in a sequential order till the end of the list. If there are 10 elements, then I will be comparing with the 10 elements. If I find it at the fifth location, then I will stop there. Then I'll stop the searching procedure there and tell that my search is successful, and then I will not proceed further. I will just stop there. That is. This searching technique is most suitable for small list of elements. If my data is 10 elements or 20 elements like that, then this linear search will be efficient and will be applicable, and can work properly. That is, it can give the result in minimum number of iterations, that is minimum number of steps. If my list is big, then linear search technique will not give such a efficient searching time or searching procedure. See, now I am going to demonstrate the linear search algorithm. For this, I have considered an array of size A, and the number of elements in the array will be n. And I will be going to search an element, that is item, in the list of elements. And if my search ends successful, then I will be returning the location where my search element is found. Otherwise I will set the location to -1. Okay, I want to clarify that here I am taking an array of size n, and that means I will be my list of elements will be n and the array name is A, and I will be performing the search on this. If my search is successful, then I will be returning the location that where I have found the element. Otherwise I will return -1, and the element to be searched is named as item. See the algorithm here. This algorithm demonstrates the linear search technique. Here linear search, the name is given as linear search. Since I am performing linear search technique, so I have given a relevant name as linear search. And in this you can see that A comma n comma item comma location, that is A is the name of the array, n is the size of the array, item means the element to be searched. Whatever element I have to search will be item. And location is nothing but if I find the element at a particular location, that is if I find it at A of 0, then I will return A of 0. If I find it at A of 1, then I will return A of 1, like that. Otherwise I will return -1. Now begin. Begin means I start the searching procedure. For I is equal to 0 to n minus 1, that is for I is equal to 0 to n minus 1 means from location A of 0 to n minus 1. As you all know, my array index always starts with 0 and ends with n minus 1. So I start the searching procedure at A of 0, then go to A of 1, then go to A of 2, so on I proceed till A of n minus 1 by one increment, that is first A of 0, then again A of 1, then again A of 2. One step like that I will go till the end of the list. Next, what I have to do? I have to perform the searching technique. Now, if A of I is equal to item, then set location is equal to I. If I find the element at A of 0, then return 0. That is, the location is nothing but A of 0. If I find the element at A of 1, then return A of 1. Here, if A of I is equal to item means if the element at location A of 0 is matching with my key element, that is the element to be searched, then I will say that I found the element at A of 0. If I don't find the element at A of 0, then again I proceed to the next step, that is A of 1, and compare my element with the element at A of 1. If it matches, then I return A of 1. Otherwise, again I go to A of 2 location and compare my key element with the element at A of 2 location. Like that, I perform the search till the end of the list. If I find the element at any location, then I will return the value of the location. If I find it at A of 0, then I'll return A of 0. If I find it at A of 1, then I will return A of 1 and exit the loop. Otherwise, if I have not found the element until I have performed the search from A of 0 and to A of n minus 1 and I have not found the element at all, so then I will return as location is equal to minus 1. That is, my search is unsuccessful and I have not found the element, and I will end the linear search. If you understand the algorithm clearly, if you see the algorithm clearly, then you can clearly understand. Here in this there is a loop for I is equal to 0 to n minus 1. That is, starting from the first element of the array, I will compare till the end of the end of the list, that is end of the array. If A of I is equal to item means if the element I want to search, that is item, is equal to the item in the array, that is at A of 0, then I will return I found the element at A of 0. That is, set location is equal to I means if I find the element at any location, then I will return the location name. Set location is equal to minus 1 means if I don't find the element and I have started my search at A of 0, then went to A of 1, so on, A of n minus 1, I have reached the end, I did not find the element, then I will return minus 1. This is very simple algorithm, very easy algorithm, and for every searching procedure or sorting procedure or any technique in data structure, you need to by heart or you need to learn the algorithm clearly. This plays a major role in your exams or anything. You should demonstrate or you should write the algorithm clearly in any examination. Now, coming to the efficiency of linear search algorithm. For any algorithm, there will be two factors affecting the algorithm complexity. That is, for saying that it is an efficient algorithm or best algorithm, there will be two factors that is affecting. One is time complexity and other is space complexity. This linear search algorithm or a sequential search algorithm searches for a list of searches for an item in a given list of an list in a sequential order, that is starting from the first it will go to all the locations, all the memory, that is a of 0, a of 1, a of 2, so on till the end of the list. If the match is found, that is if the search is successful, then it is okay, otherwise the search will be stopped at the end. This is a less efficient algorithm when compared to binary search or any other searching procedures. Now coming to algorithm complexity. Now see, suppose X is an algorithm and N is the size of input data. The time and space used by the algorithm X decide the efficiency of X. Here they are saying that X is an algorithm and N is the size of the data. Now the main factors that affect the efficiency of an algorithm is time factor and space factor. What is time complexity? Time complexity means nothing but the time taken to perform all the operations starting from the first step to the ending step is known as time complexity. That is the overall time the algorithm or program takes to execute is known as time complexity. What is space complexity? Now, the space complexity is nothing but the space or the memory space taken by the algorithm, that is to store the variables, constants and everything, the functions, everything in the memory comes under this space complexity. For calculating the efficiency of any algorithm, we will take the time complexity as well as space complexity. Based on that only we will decide whether an algorithm we have written is efficient or not. That is, if my algorithm takes 10 minutes to execute and the other person algorithm takes 20 minutes to execute, then my algorithm will be considered as best because it is executed in less time. If my algorithm takes a little memory space and other person algorithm takes a little more extra memory space, then my algorithm will be considered good algorithm as it is consuming less memory space for storing any variables or any data during the program execution. Based on this time complexity and space complexity, and we can analyze the algorithm. Based on this only we will be accessing the worst case, best case and average case. Now coming to time complexity analysis. Linear search time complexity analysis is done below. Here see the best case. If I have a list of 10 elements and I am searching for an element in that list of 10 elements. If my key element matches with the first element, that is A of 0, the element at A of 0, then I will perform the search in less number of time and I will store less data in the memory. Then that search will be known as best case. That is, I found the element at first location only, so I will not go to the next locations to search, and I can end the search in little time only, minutes of time or seconds of time. So I am not going to other array elements, or I am not continuing the search further. I will end the search and with one comparison only, that is first element is compared with my key element and I found the element and my search is successful. Then I come back, that is, and I say that my element is found and my search is successful at the location at which I found the element is A of 0. So it involves less time and less storage space. Such an algorithm or such a case is known as best case. That is, I perform only one comparison. Okay. Next, worst case algorithm. What is a worst case in an algorithm? Here let us consider the linear search. In this linear search I have 10 elements. I have one element to be searched. I start from the first element. I compare my element with the element at A of 0. My element does not match. I go to A of 1. Then compare. Then element is not found. Again I go to next location A of 3. Then I compare my item with the element at A of 3. My element and that element is not matching. Then again I go to A of 4. I compare the element with the element at A of 4. It is also not matching till I'll go till the end of the list. That is starting from A of 0 I go to A of 9. Since I have 10 elements I start from A of 0 and go to A of 9. I don't find the elements, or I find the element at the last position, then it is called as the worst case algorithm. Worst case, that is, if I don't find the such element, then I have all done this waste only. That is, starting from A of 0 I have gone to A of 1, A of 2, A of 3, so on. I have gone to different locations and searched my key element until the end of the list. I don't find the element, so my search is waste, my time is waste, my space is waste. So this is the worst case. That is, we can give best case and worst case in O of n representation. Best case is O of 1. That is, I compared only one comparison. I performed only one comparison. So its order is O of 1. The worst case is O of n. That is, from 0th location to n minus 1, I have performed n operations. So that is, worst case is O of n. Now coming to an example on linear search. Here this is an example for linear search procedure. In this given list of elements there are how many elements? 7 elements. That is, this array contains 7 elements from 0 to 6. In this I have to find the element 15. See here, 0th location, first 2 3 4 5 6. First, before searching I have given the numbering for the every search or every element in the array before starting. Now I start the search and I start the search at the location 0. I compare my element, that is my searching element or key element to be searched is 15. First I search the element 15 with the element at 0th location, that is 92. Does 15 match with 92? No. So my search is unsuccessful. Again I go to the next location, that is location 1. Now my key element is 15 and the element at location 1 is 87. I compare 87 with 15. Does it match? No. Go to the next location. In the location 2, what is the element? 53. My key element is 15. Now compare 15 with 53. Are those matching? Same? No. Go to the next location. Now come at location 3 we have 10. My key element or the element to be searched is 15. Now compare 10 with 15. Does both match? No. Go to the next location. Now at location 4 the element is 15 and my key element is also, the element to be searched is also 15. Now compare 15 with 15. They are matching. So my search is successful and I found the element at location 4 and I end the search there only. I don't continue the search because I found the element at location 4. I end the search there only and come back and return the index position or location as 4 and my search is successful. See, I have demonstrated all the steps in this PPT. See, it compares elements with 15 with the first element 92. Since 15 not equal to 92, so required element is not found, and so move to the next element. Like this I have written all the steps clearly. So see the steps, and when you solve any example, write like this only. See, step 1, step 2. In step 2, I compare the element with this element at the second position. In step 3, I compare my key element with the element at third position. In step 4, I compare my element with the element at location 4. And in step 5, I compare my key element with the element at fifth location. Since I found the element at the fifth location, I return that status or index as 4, and I say my search is successful. See, what are the advantages of linear? Now coming to the advantages of linear search. It is a simple searching technique, very simple, and everyone can easily understand it and easily implement it. It does not require any sorted array or like that. The elements in the array can be in any order. It does not require any particular order, and it does not depend on the number of directories or number of elements on the list. And if the element is the first element, then the search ends very quickly. In short, we can say that this searching technique is a simple to implement and also simple to understand. When the elements are limited, that is the list of elements are small, then this searching technique will be the best thing. Now coming to the disadvantages of linear search. As I have already told, this searching technique is best when the number of elements in the array are limited. That if my array contains only 10 or 20 elements or 30 or 40 elements, then this linear search will be efficient and can be implemented easily. If the number of elements increases, then the searching procedure will not be such an efficient technique, because while moving from one location to other location, I move in a sequential order from a of 0 to a of 1, a of 1 to a of 2, a of 2 to a of 3, like that till the end of the list. And if I found the element at the last position, then I will consume a lot of time and a lot of memory. So this is poor and inefficient when the number of pages or number of things to be searched is many. That is, I am going to search an book in a library, small library of 100 books, then I can search it in quickly. If the library contains 10,000 books and I have to search it in a linear fashion, then my search will become very difficult. Such is the linear search technique. If the list is small, then linear search is best. If the list of elements to be is big, then this search is not such an efficient technique. Now this is an assignment for you. Apply the linear search technique on the following list. See, I have given two problems. That is, in the first one I have to search the element 24 in the given list of 10 elements. You have to perform the linear search procedure on the two problems, clearly specifying each and every step neatly, and submit the assignment within 3 days. That is by Wednesday. See, in the first list you have to search the element 24 in the given list, and in the second you have to search the element 4 in the next list of elements. Okay. By this I come to the end of class 3. Okay. Thank you. Thank you.